So this kind of paints the picture of what we're going to be looking at through this next unit. And let's kind of take a step back and kind of go over a review of the electromagnetic spectrum. Because you're going to be using various forms of radiation in the entire next couple labs for the real project. Okay? First thing is, when you hear the word radiation, everybody wants to think it's bad and everything like that, right? Radiation can be very, very harmless. So try to get the notion out of your mind that, hey, this is really bad stuff. Okay? So let's look at the electromagnetic spectrum. And this is something that's first introduced in chapter 6 of our textbook. But I kind of want to go over some things and hit on a couple things that we're going to be using in the real project. First of all, a very small sliver in this large electromagnetic spectrum is visible radiation. This spectrum is going to extend in both directions, and in terms of all the radiation that we analyze, the visible spectrum is just this tiny little sliver that exists. In your labs coming up, we're going to look at visible radiation. We're also going to look at ultraviolet radiation. We are going to use X-rays in the lab. And more potent than X-rays are gamma rays. We're not going to be playing with those. So in terms of the electromagnetic spectrum, over here is our high energy radiation. If you have a high energy, we have a low wavelength or a small wavelength. Okay? We also have a high frequency. And frequency is abbreviated as the Greek letter nu. And we can remember back from some of the equations from Chemistry 121, remember that E is equal to hc over lambda, or E is equal to h nu. The radiation that's even less energetic than the visible spectrum is infrared radiation, followed by microwaves and radio waves. So these are the low energy end of our spectrum. One of the things that I want to focus on, and in this transition metal analysis, we're going to look at various wavelengths of radiation and why we can visualize the colors that we do. So let's kind of focus on this middle section here in the visible spectrum. And I expect you to know roughly that this visible region of the spectrum spans from approximately 400 nanometers to 700 nanometers. I say approximately because everyone's eye is probably just a little bit different. So we range from about 400 to 700 nanometers. I expect you to know those numbers off the top of your head. And I also expect you to put all these radiation in order of increasing or decreasing energy. This would include the colors that are in that spectrum. Okay? We have the Roy G. Biv acronym that we use, right? And when we put those in order, we have ultraviolet radiation, which is higher energy radiation from the sun, right? Right next to the ultraviolet is going to be the violet end of the visible spectrum. The infrared radiation is not quite as harmful, right? The red visible photons are going to be less energetic than the violet ones. So then we can just use the Roy G. Biv and put them in the proper order. And now we have them arranged. And you should be able to logically think through that. So this is our types of radiation, the types of visible radiation that we're going to see, and the various wavelengths that we're going to observe. One of the things that we need to definitely hint on is that when we look at these, this electromagnetic spectrum is an entire spectrum that spans from one color to another, and it's continuous. It's kind of like when you have a prism and you take light through it and you see the little rainbow on the wall. That's perfectly continuous.